Oh, hi there. My name's Cassie. I'm an FX 260 scientific calculator. Notice I'm solar because I care about our planet. Some General Chemistry 2 students find my complex set of buttons to be intimidating or frightening, but there's nothing to be frightened of. Come with me to my favorite spot where I like to achieve a state of deep meditation and relaxation. Ah, that's much better. I like to be here, one with the roots. Or bask in the sun on this natural log. Now it's an inverse natural log. Now let's go see Mike, and he'll introduce you to my friends. But remember, there's no reason to be afraid as long as you get to know us. Hi everybody, hi everybody, hi, Mike here, and I'm going to give you a sort of courtesy video here for you Gen Chem 2 students, and we'll talk about the calculator skills you'll need to have. And there's about 3 things that occur in Gen Chem 2, and I see that even though folks have gotten past Gen Chem 1 and they're in Gen Chem 2, they still struggle with how to use their calculator, and it costs some points on exams and stuff. So I'm going to talk about 3 places in the course where it's necessary to have very intimate knowledge of your calculator and in their appearance as far as the course goes. So the first is natural logs, or inverse natural logs. You talk about that with vapor pressure. Next would be cube roots and cubing things. Talk about that in unit cells. And then base 10 logs are where we talk about pH and pKa and pOH and a p anything. So let's go first with natural logs. And I have a series of bunch of different calculators here that we can kind of talk about. So let's first of all talk about why we need to express things in natural logs. Natural logs are sort of how we explain the language of exponential growth. So if we have something like this, this is temperature, right? And this is vapor pressure, which we're going to get into quickly here in the very first part of the course. That's a curve. And curves are exponential, which means, something's going to double, for example, at a certain interval. And it's not just a straight line. And so where you find that, and that's base E. Now, E stands for Euler's number, which is the natural sort of interval that something will kind of compound itself or grow. You don't really have to understand much about E intimately. It's 2.71. if you want to ever check yourself. And so you will find that if you have one of these calculators, you ain't got no natural log, you ain't got no E, you might as well throw that thing away. You can get through Gen Chem 1 with one of them, and even scientific notation, but with logarithms you can't. You're going to need some form of scientific calculator. All right, I have an HP and a TI, and we can, I got an that was a TI, and I got an HP. So we'll do a calculation, we'll do it all on different calculators, and I'll talk about how you do that. So the first thing is a natural log of something and an E to the raised to the power. Those are opposites of each other. So a natural log can be undone by an e to the x, So if you do natural log of e to the x, you just get x back again. And if you do e to the natural log of x, you get x back again. And so you will notice one of the reasons it's great to have a scientific calculator is if you notice that you got the natural log button right there. And then the second function almost always is the e to the x button. So here's a TI calculator. It's a TI 85. This would be like your TI anything. And here's the natural log button. And then if you look, the second button is an e to the x. And so here's an HP. I'm not as good at HP, so this might take me a while. Where's natural log here? Probably should have looked before we started. But anyhow, if you go and look, and I'm looking for it, you guys probably are like, it's right there, Mike. But wherever, there it is. There's a base 10 log right there. And you notice that I can't even find natural log. So we'll put that one last. I use this calculator. This is my go-to. So what we're going to do here is just a couple calculations where we're going to, let's put in natural log of 0.5. There's a point where that comes in. By the way, half-life is another place. So we're going to do 0.5, and then we're just going to hit the natural log button, and we get minus 0.693. Now let's do an e to the 0.5. These are going to be different numbers, by the way, and I'll show you a proof that shows you how a natural log and an e to the x are related. So now I'm going to go 0.5, and I'm going to go to the same button as the natural log button, and I'm going to hit second e to the x, and I get 1.649. Now the thing is, to prove that an e to the x and a natural log sort of undo each other, you will notice that if you do 1.69 to the negative 0.693 power, you get 1. That kind of proof that they cancel each other out. All right? So let's go do a 0.5 natural log and see what we get on this calculator. So turn it on. This is a TI 85. And then I had to hit clear. And so I'll hit 0.5. Now on some of these you have to actually push the button before, but see what I did there? So what I have to do is I have to go and push the natural log button, and then it has a parenthesis. So it says natural log, and then I could say 0.5, and then hit enter. And there's my negative 0.693. So just keep in mind, all calculators are different. That's why you should be doing this along with me, and then sort of, going along and doing that. Here's this. Now, folks, look I don't use this calculator ever, and so that's why I'm struggling here with where the heck natural log is. And I'm looking for an e to the x, and I'm looking for okay, you know what? I got frustrated and I gave up. But you know what I could do? Here, let's say I got to do the e to the x, 2.71, and then I hit this y to the x button. That caret means raised to the power of, what was I going to do? 0.5, and I'm going to get 1.649. 0.5. Enter. There you go. Close enough. Yeah, it's 2.71 something, but so now I'm going to, since I get as many calculators as I want, because students leave them for me all the time, I'm just going to choose not to use that one. I have the privilege of having numerous calculators at my disposal that are left behind by people. Here's your calculator app in a phone. Now let me tell you why this is a little risky. There is a scientific calculator in this particular app, but do you notice where the e to the x button is not on the same button as the natural log button? So that's kind of troublesome, because the way you remember that an e to the x is the opposite of a natural log is you pick up a calculator like this Casio, and it'll show you that, that's natural log and that's e to the x. So usually the second function is sort of the opposite of what that function is. So that's why I think, as much as this is on your device and all your, you can always go and go back and look, and you got your, oh, hey, I got a Snapchat, right? Okay, that's great and all, but I find the app on phones to be a little more confusing than just, footing the $10 and getting a calculator that's scientific. So let's talk about the next problem that is going to be something that greets you in Gen Chem. And that is if we do, oh no, I'm sorry, I forgot one more thing. Another natural log thing. Let's say we had to solve for x here. What am I going to do? Well, I got to get at what's in the parentheses. And so the way to undo that is I do an e to the x on both sides of the equal sign. So what happens is you got to do the same thing, same operation to both sides of the equal sign. So an e to the x sometimes is also called inverse natural log. They're the same thing. And that would convert the left side of the equation to 0.2 over x. It just gets rid of the natural log. And now that means you'd have to do an e to the minus 2.772. So this is the nearest calculator I got handy. So 2.7, oops, negative. I gotta make it negative. Where's my positive negative? Right there. 2.772. And then I'm gonna go hit the shift button. And then I'm gonna hit that's e to the x. And then why the heck didn't it do that? That's when you go get another calculator. Negative, did I make it negative 2.772? Hold on. Once again, you know, get your trusty calculator. 2.772. This is the one I like better because I just have more experience with it. It's not any better. Second, natural log, there you go. 0.06625. Why the heck did it give me an error? Oh, well, I can't even clear it. So maybe this one's freaking out. That's what we call in science freaking out. So then let's take this TI just so you can see that I'm not making stuff up here. Clear. And what did I have to do? Minus 2.772. And then this is one of those ones where you have to put it in to begin with. So I'm probably going to have goofed this up because I want to go and find my natural log button, which is right there, and go second e to the x. See, now that's where I had to put it in first. So I go second function e to the x, and then in parentheses I put minus 2.772 and then parentheses. So that's a bit of a pain. And then I hit enter. And there's my 0.062. And now I'd have the ability to go and solve for x. And so you're going to have to do stuff like that kind of often. So, okay, what's the next thing that pops up is cube roots and cubing things. So let me show you where the phone is a bit of a pitfall. But first I'll do this easy. Well, you might have a cube root button on your calculator, and if you don't, there's ways to deal with that. Not a big deal. So let's go ahead and take my trusty TI-30XA and clear it. And let's say I had to take that number. Now, by the way, I have a separate video for scientific notation with all these things, because sometimes people put scientific notation in wrong. 1.71 times 10 to the minus 22. Now what I want to do here is I either have a cube root button right there. You can see it maybe. Cube root button. There it is. It's got a little 3 over the root sign. Or if you don't have a cube root button or you can't find it, I got a trick for that. But let's go ahead and I'll hit the cube root button. Now this is something you can't do with a regular calculator because, you know, cube roots are hard. You can't just do them in your head unless it's round numbers. So this is a very, very small number, like the volume of a unit cell. And so when you take the cube of it, it should be a much less smaller number. So I'm going to go ahead and hit my cube root button. So, and now what you got to do also is convert it back to scientific notation. So it's 5.55 times 10 to the minus 8. How do you check yourself? If you multiplied that by itself 3 times, you'd get the above number. That would be cubing it. So now, let's say you can't find a cube root button. Like, let me take this thing. And I should have practiced before I did this video, but it's kind of neat for me to show you the actual struggle you go through sometimes. So, okay, 1.71. This double E on this calculator, that E right there, means times 10 to the something, and it was minus 22. Now, if you don't find yourself able to locate a cube root button, you probably got this caret thingy here. And then I can go, I probably should have put parentheses around it. Let's see if it gives me the right answer. And then that's not 0.33333, because a cube root is to the 1/3 power, right? And there you go. That's my number, 5.55 times 10 to the minus 8. So do it along with me and see if you get a matching value. So okay, I'm going to go back and preach more about how the calculator app on your phone might not be too cool sometimes. So we're going to go to scientific calculator and a 1.71. So here, these things you got to use a lot of parentheses. See, so you don't have any exponential notation thing. So you could just say, you know, times 10, and then you go to this y to the x button, minus 22, minus 22. I think I put another parentheses in there too. We'll put another. Then I go and you know, hit enter, you know, equals, and then you see what that did. That cubed. No, dang, sorry, it didn't do nothing, Mike. So then you go, and then y to the x, 0.3333, and okay, it did it. I just don't like the parentheses business too much, and I can avoid it on some things. All right, let's go do the last thing we're talking about, and that's a little bit easier to understand. That's base 10 logs. So what happens in Gen Chem 2 is we deal with numbers that are fantastically small, like the number of moles per liter of hydrogen ion in a solution, for example, which could be that number right there. And that's very, very, you know, what if we said to somebody, hey, the concentration of hydrogen ion in pure water is 1.0 times 10 to the minus 7 moles per liter. Well, you know, that's really clumsy. So what we do with large ranges of numbers is we squeeze them down with logarithms. Log just tells you what power 10 something is. So the opposite of a log is taking 10 and applying that power to it. So you can look at this, and it's not like a natural log. You can kind of get a gauge here. I'm going to have to move the decimal point 1, 2, 3 times. If that was 1, you know, 0.001, the log of that would be negative 3. That's saying that that's 10 to the negative 3, which is like saying 1 divided by 10 times 10 times 10. Well, this is a little bit bigger than that. So I'm going to get a log that's a little bit, not quite negative 3, and in between negative 3 and negative 2. It's going to be negative 2 point something. See? And so the number of places you have to move the decimal tell you what the log's going to be. So that's good to have in the back of your mind. So, okay, 0.00178, and then I just got a log button, and I hit the log button, minus 2.7495. Let's call that minus 2.75. Okay? Now, what happens if I take minus 2.75 and I do that times 10 to the minus 2.75? Well, it's the same button as the log button. So darn, I shouldn't have done that. I should have just kept it on the screen. So if I go 2.75 negative, and then I hit the opposite of the log button, which is 10 to the x, I get that number right back again, 0.00178. So the opposite of a log is a 10 to the x. What I did there was I went 10 to the minus 2.75. And then it's good to have your bearings with powers of 10. 10 to the minus 1 is 0.1. 10 to the minus 2 is 0.02. And so, you know, that when you do that, it's telling you what power 10. So 10 to the minus 1, if you take a log of that, that's minus 1. 10 to the minus 2, the log of that's minus 2. If you had 1,000, the log of that is 3. And so you say take a huge range and you squeeze it down with logarithms. So those are the things, folks, you need to know where to find it. Even on HP, I can find the log button. You know, I can find the log button on an HP even. So, you know, what do we do there? 2.75 or 0.00. Oh, remember, sometimes you got to hit the thing first. So I might have to go and hit second and then log. See? And then I go 0.00178, and then I puts parentheses in for you. Is that what it does? I don't know. There you go. And so find yourself a calculator with all 3 of those functions on it. I know I couldn't find natural log on that. That's why I would choose for some of the others. Hey, look, that's a calculator from the dollar store. And I can quickly see that there's a natural log button on it and a log button, just from the dollar store. Costs you $1. Problem is, when the batteries go out, you've got to take the back off. And then the batteries are weird, like they're at LR 1150 something. So that's why I don't use that one anymore. So folks, that was a little bit of a refresher, because I do get into problems with people struggling with calculators, even as far as Gen Chem 2, which is a very numbers-oriented course. So hopefully that will set your bearings straight, and you know, get to know your calculator again. You might have taken a month off from it over winter break. You might have taken the whole summer off. You might have taken 7 years off of the thing. But get to know it, throw a battery in it, polish it up, maybe sleep with it under your pillow one night just to get used to it again, and I will see you next time. Ciao for now. Bye.